Good afternoon, everybody. Thank you for staying with us. It's my great honor to be here to share with you our thinking over the last 15 years about sustainability and future power systems, what we call synchronized and democratized smart grid, in short, SYNDEM. I would really like to thank President Qing-Chang and his team for inviting me and the nominators for nominating me. I enjoyed the performance last night here very much, and I'm sure you did so as well. It demonstrated perfect harmony, and this is the key word in my talk today, harmony. We live with power systems and electricity every day. In 2000, the US National Academy of Engineering selected electrification as the greatest engineering achievement of the 20th century. Power systems are also regarded as the largest and most complex machine engineered by humankind. Power systems are getting even larger. In Europe, a lot of high-voltage transmission lines are planned to link the power systems of member states together. In the US, a lot of high-voltage AC links and DC links are being built to link the Eastern interconnection, Western interconnection, and Texas interconnection together. In China, a lot of high-voltage DC links and high-voltage AC links have been built to form a smart and strong power system in China. At the same time, power systems are being democratized as well. A huge number of relatively small renewable energy sources, such as wind turbines, solar panels, and also electric vehicles and energy storage systems are being added onto the grid. We have often heard that the merging of renewable energy and the internet technology is creating a powerful third industrial revolution. So power systems are getting larger with a huge number of relatively small distributed generators added to the system. This causes unprecedented challenges to power systems and may lead to blackouts. This slide shows you the top 10 blackouts happening in the world. 5 years ago, the largest blackout in the world happened in India, where 670 million people were left without electricity. Last year, in September, a blackout happened in South Australia, where 850,000 people were left without electricity. The final report says that this is due to the increased amounts of non-synchronous and inverter-connected plants. So there are many possible reasons for a blackout, but for us system engineers, the question for us is that how to sustain growth and maintain stability. This is very challenging, right? History often has the answer for questions like this. When we talk about history, we have to talk about China. Let's spend 100 seconds on the history of China. Please, video. Thousands of years ago, several cultures emerged in the East, where China is now. About 5,000 years ago, Chinese characters were invented and have been evolving since then. About 2,300 years ago, that land was highly democratized with 100 schools of thought, such as Confucianism, legalism, Taoism, and Maoism. However, it was filled with chaos and bloody battles. In 221 BC, Emperor Qing united China and unified Chinese characters, currency, trade, and communication. This has laid a structurally stable foundation for Chinese culture. He means harmony. It lies in the center of Chinese culture and has safeguarded its stability and prosperity, even after being invaded. With this, Chinese made great inventions such as printing, papermaking, compasses, and gunpowder. This harmonizing principle has also been instrumental for 1.4 billion Chinese to live in harmony. Today, I will talk about how to harmonize democratized power systems with this principle to make our planet more sustainable. The fundamental challenge behind these challenges is that future power systems will be power electronics based instead of electrical machines based, with a huge number of non-synchronous, incompatible players. Then, how are we going to operate our future power systems? In the short video I showed you that the harmonizing principle has brought sustainability to China for over 2,000 years. If we want to have sustainability for our power systems, is it possible to harmonize or unify our power system players so that they can bring sustainability to our power systems? Remember that I mentioned that China was highly democratized before being harmonized. And now probably you have heard some visionary leaders talking about democratization of power systems. But can we really democratize power systems technically? Democracy is a political concept that empowers all eligible individuals to play an equal role in decision-making. However, significant difference or even divisive opinions could appear in a democratized society. We have seen several examples in recent years. This is not acceptable for power systems. A power system has to maintain the stability of frequency and voltage. That means all power system players should synchronize their actions for the same goal. That means in addition to democratization, we also need synchronization. This leads to synchronized and democratized smart grids. For a democratized society, there are two important features. One is the rule of law, and the other is called the legal equality. For the rule of law, it means all players should follow the same rule. For the legal equality, it means all players are equal and should be treated equally. It is this intrinsic synchronization mechanism that has underpinned the operation and growth of power systems for over 100 years. So the natural rule of law for SYNDEM grid is the synchronization mechanism of synchronous machine. Indeed, in this way, most nodes can be equipped with the synchronization mechanism and play an equal role in regulating system stability. So, we have achieved legal equality. Whether they are conventional or new add-on generators, whether they are generators or loads, whether they are large or small, they can all behave like virtual synchronous machines or synchronous machines and follow the same rule of law, the synchronization mechanism. Now, it's time to show you the SYNDEM grid architecture we have proposed. This synchronized and democratized smart grids has got this architecture. So in this architecture, the conventional power plants, the coal-fired power plants, nuclear power plants, hydropower plants on the top of this graph, they can be collector grid in the conventional way without much change through conventional synchronous machines, SM. For the new add-ons of generations, wind turbines, solar panels, DC microgrids, electric vehicles, energy storage systems, you can control the inverters as virtual synchronous machines so that they can behave like virtual synchronous machines. And for the rectifiers, for the loads, we can control the rectifiers as virtual synchronous machines as well. For the high voltage DC links, they have two power electronic converters. So we can control both converters as a virtual synchronous machine as well. So one as a virtual synchronous generator, one as a virtual synchronous motor. Now, if you look at all these active players from inside this graph or from the transmission and distribution network, whatever you see will have the mathematical model of a synchronous machine. So that means we have arrived at a unified or harmonized architecture. These active players can work with each other autonomously to regulate the system stability without relying on communication network. That's wonderful. So we have made a super large-scale complex power systems with many heterogeneous players to be operated with one goal, that is the stability, with one principle, that is the harmonizing, and one action, that is to turn power converters into virtual synchronous machines, with the synchronization mechanism and arriving with a lateral architecture. So I want to point out that simplicity is beauty. This architecture is lateral rather than hierarchical. It's very interesting. This is a lateral architecture or a flat architecture. And this actually provides a technical solution to implement the lateral power envisioned by Jeremy Rifkin for the third industrial revolution. I have shown you that we can all make contributions to our sustainability, but we are not able to do this by our own. We need everybody, you, to join us to make our planet sustainable. If you want to learn more about this area, to know the latest updates, you can join the LinkedIn group we set up for virtual synchronous machines. And in order to speed up this commercialization process, we have set up a company called SYNDEM LLC to further develop the technologies and make the technology available so that we can deploy SYNDEM smart grids worldwide. If you are interested in this, please let us know, and we will be very happy to work with you to make contributions to the sustainability of our planet.